An object from another star system just broke every rule we thought we knew about comets. On October 29, 2025, 3I/Atlas, only the third interstellar visitor ever confirmed, did something that left astronomers completely stunned. It didn't just brighten, it erupted with a ferocity that defied all our models, venting incredible amounts of gas while its dust mysteriously vanished. This wasn't a predictable celestial event, it was a cosmic anomaly that challenges our fundamental understanding of objects formed around other stars. Let's explore this together. The alarm. It began with a single, jarring spike in the data. On the night of October 28, 2025, the steady stream of information from our solar observatories was shattered. STEREO-A's instruments designed to watch the sun picked up a sudden massive surge in brightness from 3I/Atlas. This automated photometric data is the frontline defense for detecting unexpected events, and this one was a 5 sigma alert. Within minutes, the same alarming signal appeared in data from the SOHO spacecraft's LASCO coronagraph and the GOES 19 satellite. At the Naval Research Lab, astrophysicist Carl Baddams, a real-life expert who manages these projects, was the first to see it. At 1:26 UTC, he flagged the jump in his team's internal chat. The numbers didn't fit any known model. 20 minutes later, halfway across the world, astronomer Quanji Ye at the University of Maryland independently confirmed the break. The object's brightness was now climbing at nearly double the speed it had just days before. With the object lost in the sun's glare for all ground-based telescopes, these space-based assets were our only eyes on the event, and they were sounding a clear, unambiguous alarm that something profound was happening. Breaking models. This wasn't just an outburst, it was a complete violation of physics as we know it for comets. The data showed the light curve, the graph of its brightness over time, had steepened to an R to the -7.5 power slope. To put it simply, that's a rate of brightening so extreme it suggests an almost explosive release of energy, far beyond simple sublimation. No comet model, not even for the most volatile objects from our own Oort cloud, had ever predicted such behavior. The scientific community was caught completely off guard. As Carl Baddams and Quanji Ye confirmed the numbers, chat channels filled with confusion. Every known comparison failed. An object this close to the sun simply does not double its rate of brightening like that, without a clear massive fragmentation event, which wasn't being seen. The photometric alarm wasn't just telling them the comet was changing, it was telling them that every assumption they had about interstellar visitors was wrong. For a seasoned observer like Ye, known for his work on the active interstellar comet 2I/Borisov, the data was both exhilarating and deeply unsettling, a sharp reminder of how little we truly know about the diversity of objects in our galaxy. Chemical clues. So, what was driving this impossible explosion of light? The answer had to be in its chemical fingerprint. As the alarm bells rang, spectrographs went to work, translating the raw light into its core components. The first clues were classic signs of a comet in distress. Strong C2 swan bands which glow with an unmistakable blue-green signature, and NH2 emissions from ammonia. These signals told astronomers like Quanji Ye that volatile ices, likely frozen for billions of years, were breaking free from the nucleus and vaporizing under the intense solar heat. But the story was deeper than that. The color of the coma, the atmosphere around the nucleus, began to shift dramatically towards blue. This is a hallmark of an object whose light is dominated by glowing gas, not reflected sunlight from dust. In a normal comet outburst, you get a broad reddish tail of dust. Atlas had none. This was a pure, raw chemical event, revealing a composition or physical process unlike anything seen in comets from our own solar system. The sheer lack of silicate or carbonaceous dust signatures was a glaring omission that pointed to a very alien origin. Ultraviolet surge. The most critical evidence, however, came from a type of light we can't see. The SWIFT satellite's ultraviolet optical telescope became a key player, hunting for the chemical signature of water. In comet science, astronomers look for OH, or hydroxyl radicals, which are created when solar ultraviolet light splits H2O molecules in a process called photodissociation. OH is a direct and reliable proxy for water. As the brightness curve of 3I Atlas went vertical, SWIFT's detectors saw a massive surge in OH emissions. The data, carefully analyzed by teams working through the night, was precise. water production rates had soared to roughly 5.7 times 10 to the 28th molecules per second. That incredible figure is nearly 40 times higher than what was measured just a month earlier. This finding, tracked by scientists like Carl Baddams, who coordinate multi-mission observations, confirmed that the outburst was driven by a deep-seated violent release of gas, primarily water vapor. The timing was perfect, aligning exactly with the brightness anomaly, and proving this was not a simple surface dust event, but a catastrophic internal change.
Space eyes.
With Earth-based telescopes blinded by the sun's glare, humanity's only view of this extraordinary event came from our robotic eyes in space. The coronagraphs aboard STEREO-A, SOHO, and JWST stared into the solar glare and recorded an object that defied every visual expectation. A coronagraph is a special instrument that blocks the sun's overwhelming light, creating an artificial eclipse to see faint objects nearby. Where there should have been a familiar, fan-shaped plume of dust stretching away from the sun, the images revealed something else entirely: a large, smooth, and elongated coma, about 4 arc minutes across. This glowing envelope was bright, holding steady near magnitude 9, a level that should have produced a spectacular dust display. Yet the data told a different story. Analysts, including those on Carl Baddams' team, scoured the pixel-level details, looking for any sign of jets, a faint tail, or any structure that might betray the presence of solid grains. There was nothing, just a massive, featureless cloud of glowing gas. The object was so bright it risked saturating the sensitive detectors, forcing the team to adjust their analysis techniques on the fly.
Missing dust.
The central mystery wasn't what the space-based coronagraphs saw, but what they didn't see. A spike in water vapor and volatile gases of this magnitude should have been accompanied by a blinding surge of dust. In every comet from our own solar system, escaping gas acts like a rocket engine, dragging tons of dust and rock from the surface and lofting it into a brilliant tail. But 3I Atlas seemed to be venting its gas directly into the void, with little to no solid material joining the outflow. The blue-ward color shift, confirmed by photometry from JWST, only hammered the point home. This was a gas-dominated event. The dust-to-gas ratio, a key diagnostic in cometary science, was completely off the charts, far lower than any known comet, active asteroid, or centaur in our solar system. The missing dust became the most important clue. Was this interstellar visitor simply made of different stuff, poor in dust to begin with, or did its internal structure somehow prevent solids from escaping? This was a puzzle that left imaging analysts completely stumped and hinted that the story of this object began far, far from our sun.
JWST's discovery.
So, the answer to the mystery of the missing dust, well, it came from data gathered months earlier. Back in July 2025, while 3I Atlas was still cruising towards the sun, the James Webb Space Telescope's NIR-SPEC instrument took a really close look. Heidi Hammel, a renowned planetary scientist and a key leader for the JWST program, described the results as both a surprise and, a warning. The surface of Atlas was anything but pristine, you see. The data pointed to a thick crust, 15 to 20 meters deep, forged by billions of years of cosmic ray bombardment during its long journey through interstellar space. Now the chemistry was, well, bizarre. The carbon dioxide to water ratio was nearly 8 to 1. Far beyond what is seen in local comets. This was the smoking gun. Lab experiments show this exact chemical signature is created when ices are blasted by high-energy radiation for eons. The pristine material from its home star system, if it still exists, lies buried deep beneath a shell sculpted by cosmic history. This was not a window into another world's birth, but a diary of its lonely, multi-million-year voyage through the galaxy.
Cosmic armor.
This wasn't just a surface layer, it was a suit of cosmic armor. The JWST data revealed a comet fundamentally altered by its journey. The object itself is enormous, with an estimated mass of 33 billion tons, roughly half again as massive as Halley's Comet. To wrap a body that size in a crust, tens of meters thick, is to encase it in a shell, forged not by a sun, but by the galaxy itself. According to Heidi Hammel's analysis, relentless bombardment from galactic cosmic rays, high-energy particles from distant supernovae, drives chemical changes to incredible depths. This process cooks the simple ices, creating complex organic molecules and a tough, dense mantle. This armored shell acts as both a shield and a filter. It slows the escape of gas, meaning solar heat has to penetrate deep inside before anything happens. This perfectly explains the observed behavior, a delayed, sudden, and violent gas-rich outburst with almost no dust, because the gas had to build up immense pressure before catastrophically bursting through that tough outer layer, leaving heavier dust grains behind.
Rival theories.
When data breaks all the rules, incredible new ideas rush in to fill the void. The first major theory, supported by the JWST findings analyzed by experts like Heidi Hammel, is the radiation-processed crust model, but other theories quickly clashed with it. One popular idea among thermal physicists was the carbon dioxide cooling cap model, which argued that a frost layer insulated the comet until solar heat vaporized it, triggering the sudden outburst. A more exotic theory proposed an engineered nucleus, suggesting the object wasn't natural at all, and its activity was switched on abruptly once a certain threshold was crossed, a possibility that made even seasoned astronomers pause. Finally, Dr. Suzanne Falzner, a real astrophysicist who studies planet formation, has theories that could apply here, such as the idea that Atlas is a planetary building block, a planetesimal, with a distinct layered structure that fractured under stress. Each model offered clear, testable predictions about the timing, chemistry, and symmetry of the outbursts. Only more data could decide which, if any, was right.
Global sprint.
The bizarre behavior of 3I Atlas created a rare moment of unity and urgency in the astronomy community. With the comet's behavior diverging so sharply from all known models, the need for open, coordinated analysis became the top priority. The November to December 2025 window offered one last fleeting chance to observe it with Earth-based telescopes. A global observation sprint took shape. Astronomers like Quanji Ye from major observatories pressed NASA and the European Space Agency to release all raw data from STEREO-A and SOHO without the usual proprietary delays. The argument from figures like Carl Baddams was simple. No single team could solve this alone. Teams began coordinating target lists, sharing calibration scripts, and posting raw files to public servers using tools like the Astronomer's Telegram for real-time updates. Radio astronomers began listening for non-natural signals, while spectrographs prepared to search for new chemicals emerging from its sun-scorched depths. It was a race to unravel the mystery before the trail went cold. On October 29, 2025, 3I Atlas reached the closest point to our sun and broke all the rules. It brightened at twice the predicted speed, its water vapor outflow jumped by a factor of 40, and it produced a massive dustless coma. JWST data suggests it's wrapped in a 20-meter-thick crust, hardened by billions of years of interstellar radiation. Yet, the true cause of its violent dust-free outburst remains an open question. Competing theories abound, but as of now, no consensus exists. We are left with a profound reminder that even with our most advanced instruments, the universe's visitors can still leave us utterly mystified and rewrite our textbooks in real time. With observatories like the Vera Rubin now online, we expect to find many more, making this a puzzle we must solve. What do you think is the true nature of 3I Atlas? Let us know in the comments. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Thanks for watching Sci and Why.